All right, here we go. 8.3 notes. What's nice is we tie into what we learned yesterday. We're starting off with the second type that we did in the previous lesson. So if I have y equals p of x over q of x. This, for example, this would be something like, our 2x plus 1 over 3x minus 5. But we're going to extend it to much, much more complicated polynomials. So I know you're trying to write the chart stuff down, but if you can kind of, be listening. In number 1, it says the x-intercepts of the graph are the real zeros in the numerator. If you have a fraction, the only way a fraction can equal 0 is when the numerator is 0. That's going to give you the x-intercepts. You cannot let the denominator be 0. I have students each year that they set the numerator and denominator equal to 0 and call those x-intercepts. You can't divide by 0. There's a problem when you divide by 0. Number 2, though, we do end up setting the denominator equal to 0, but that's the vertical asymptote. And so this is what we've already known. Number 3, what's going to be new for us is how you determine the horizontal asymptotes. What we saw yesterday is if the degrees were equal, like I did in this example, we said the horizontal asymptote is y equals 2/3. Well, the degrees are not always equal. So here's what we're going to do. In the chart, it says we're going to let m be the degree of the numerator and n be the degree of the denominator. So if m is less than n, that means the degree of the numerator is smaller than the degree of the denominator. Then y equals 0 is the horizontal asymptote. When their degrees are equal, like here, but I can also do something like, I could have y equals 5x squared plus 1 over 2x squared plus x. If their degrees are equal, it's y equals 5 over 2. So it extends beyond just x and x. They can be x cubes, x to the 4th, x to the 5th. When they're equal, it's just the coefficients of those two terms. Now, if the degree of the numerator is greater than the degree of the denominator, there's no horizontal asymptote. So let me show you an example of how that can happen. I could give you y equals x plus 1 over x to the 4th plus x cubed. There's no, oops, I did that backwards. Huh. Sorry. Well, let me just fix this up. Sorry. I wanted the degree of the numerator to be bigger. So let's make that x to the 5th plus 2x over, x minus 3. Then, since the degree of the numerator is 5 and the degree of the denominator is 1, there's no horizontal asymptote. There's a note here underneath the table, and this is a very, very important note. If the degree of the numerator is exactly 1 more than the degree of the denominator, then there is a slant asymptote. That's not vertical, it's not horizontal, but it's an oblique or slanted line. We abbreviate it SA, and you can find the slant asymptote by doing long division. So if you remember in a previous chapter, we had fun with long division and synthetic division. So we get to incorporate that skill here. All right, everybody have it? So again, x-intercepts are found by setting the numerator equal to 0. Vertical asymptotes are found by setting the denominator equal to 0. I would strongly recommend you make index cards with these 3 on it, because after our, 40-minute lesson, you're not going to have this down. This is, you need to practice it, memorize it, and keep looking at it for the next quiz and for the next test. All right, so here we go. My goal here is to get to finish example 3. So we're not going to get very many things done, but we're going to go into great detail. Example 1 says graph y equals 6 over x squared plus 1. You always start with the vertical asymptote. To find the vertical asymptote, we set x squared plus 1 equal to 0. Now, solving quadratic equations, we typically try to factor them. This one is a sum of 2 perfect squares, and that should be a red flag to us. It doesn't factor. I should not even try to subtract 1 at this point. We want to keep our thinking caps on. If I plug in x as 0, I would get 1. If I plug in positive numbers and you square them, it gets bigger than 1. But what happens if I plug in negative numbers and I square them, they're positive, it's bigger than 1. I don't ever get 0 out. Like the most common wrong answer I get is negative 1. Well, if you take negative 1 squared, negative 1 times negative 1 is positive 1. That still doesn't work. So what this means is there's no vertical asymptote. And that will happen sometimes. Now let's determine the horizontal asymptote. When there is no variable in the numerator, that means the degree is 0. Let me say that again. When there's no variable in the numerator, that means the degree is 0. So the degree of the top is 0. The degree of the bottom is 2. Let's go back and look at the chart. The degree of the numerator is smaller than the degree of the denominator, so y equals 0 is the horizontal asymptote. You guys need to keep looking at the chart until you get it memorized. All right, now when there's no vertical asymptote, that just means I'm going to use a standard table. Let's do negative 3, negative 2, negative 1, 0, 1, 2, and 3. The good news is because I'm squaring the x, and that's the only x in the problem, all the negative ones are going to be the same as the positive. So I really only have to do half of these values. But let's start with 0. So I would plug in 6 over 0 plus 1, so that's 6. Now let's plug in 1. So I get 6 over 1 squared plus 1, that's 6 over 2. That's 3, and that means the negative 1 has a value of 3. Now let's plug in the 2. So you should be able to do these without a calculator. This is 6/5, that's 1 and 1/5. And then let's plug in 3. I get y equals 6 over 3 squared plus 1. That's 6/10 or 3/5. So we're ready now to do our grid. So I want this in the middle, and I had no negative values, so I can push my x-axis down. Now I have a horizontal asymptote. Whoops, a daisy. So don't forget to graph that. And then I'm going to plot my points. Here's 0, 6. Whoops. Here's 0, 6. I have 1, 3, but I also have negative 1, 3, so use that symmetry. I have 2, 1 and 1/5, negative 2, 1 and 1/5, and then 3 is 0.6 or 3/5. And then watch this one. It reminds me of a volcano. So I have you need to make sure you're including a table of values. Now let's talk domain and range. This graph goes forever left and forever right without lifting my pencil. So the domain is all real numbers. My range, what are the possible y values? Anybody want to try this? It's not everything because it never goes below the x-axis. It's y greater than 0. It's not greater than or equal to because it never touches the x-axis. So there's your domain and your range. And then let's talk intercepts. I do have a y-intercept of 0, 6, and it never touches the x-axis. So we say there's no x-intercept. It's like,
you need to include those now.
yes,
as well.
yes. Make sure you include asymptotes, a table, domain and range, and your intercepts. Yes?
So if there's no vertical asymptote, there's not going to be an x-intercept. Is that true?
No, that's not true. No, not if there's no vertical.
Because you can take the horizontal asymptote and it could be like -1 and you can cross the x-axis.
Yeah, you can still cross it if that horizontal asymptote's lower. Yeah. All right, let's do another one. All right, example 2 says we want to graph y equals 2x squared over x squared minus 9. All right, we're going to start with the vertical asymptote. You set the denominator equal to 0. Now in this case, because there's just an x squared, you can either factor it, because it's a difference of two perfect squares, or you could do the square root property, where you add 9 and do the plus or minus root. I tend to discourage students with the square root property because we forget to do the plus or minus root. So my vertical asymptotes are -3 and +3. Uh-oh, we have 2 vertical asymptotes. We've never seen this before, okay? So we'll see how to handle it. Now the horizontal asymptote, the degree of the top is 2, the degree of the bottom is 2. When the degrees are equal, it's just the coefficients. So does anybody want to try the horizontal asymptote? Y equals 2. And you guys be careful, do not put a 2 down. If you put HA2, I will mark it wrong. I'm being very transparent here. Because a horizontal asymptote is a line and 2 does not describe a line, it's a number. But y equals 2 describes a horizontal line. So I'm not nitpicking, it's just wrong to put a 2. All right, now, we need a table. And you might be alarmed to think, oh my goodness, how many points do I need? And it's not that bad. Here's the deal. You don't need to draw this down, but I just want to explain how I'm going to get my table. If you have 2 vertical asymptotes, I'm going to get 3 points to the right of 3, so that's 4, 5, 6. I will get 3 points to the left of -3, which is -4, -5, -6. You do not need to get 3 to the left of 3 and 3 to the right of -3. You only need 3 in between them. And you want to think about it. Like I would like 0, because 0 is always an easy number to work with. And then, yeah, you can choose -1 and 1, or you can choose -2 and 2. I think using the -1 and 1 will be easier than plugging a 2 in and squaring and adding and multiplying and stuff. Okay, so here we go. Let's go ahead, and because these are both x squareds, the negatives get changed to positives, so these are the same. Now, I don't want you to make a faulty conclusion here. If the top had just a 2x, the negatives would no longer be the same. It's because they're both x squareds, and the negatives become the same as positives. This works. All right, I'm going to start with 0, because 0 is lovely. If I get 0 over -9, that's 0. Then let's try 1. Wouldn't that be 2 over 1 minus 9? That's 2 over -8, so that's -1/4. Now that means that -1 is going to have a -1/4. So even though that's a lot of points in my table, I still only have to come up with about half of them. All right, let's try 4. Y equals 2 times 4 squared over 4 squared minus 9. That's 2 times 16 is 32. 16 minus 9, that's 7. Now, 7 goes into 32 4 whole times. That's 28, and there's 4 left over. So that's 4 and 4/7. You guys, this is elementary school math that I'm working with. So we should be okay with that. So at -4, it's the same value. Now let's do a 5. 2 times 5 squared over 5 squared minus 9. 2 times 25 is 50. 25 minus 9, that's 16. Alright, 2 goes into both of those numbers. So that's 25 over 8. 8 goes into 25 3 whole times with 1 left over, right? So let's fill that in at -5 as well. And then let's do 6. 2 times 6 squared over 6 squared minus 9. And you guys, this is really good mental work without the calculator. 36 times 2 is 72. 36 minus 9, isn't that 27? 9 goes into both of those. 9 times 8 is 72. 9 times 3, so that's what, 2 and 2/3. Alright, so let's start with our axes and then asymptote. Now the lowest I go is -1/4, so I don't need it to be that low. Alright, here's where it's interesting. I have 2 vertical asymptotes. I have x equals 3. I have x equals -3. And I had y equals 2. So this is what they were talking about in the earlier class. It's a lot of detail. It's not that it's difficult to do, it's a lot of work, okay? So then let's plot our points. I have 4, 1, 2, 3, 4 and 4/7. That's about 4.5, isn't it? So I have that same thing over here. Use your symmetry. 3 and 1/8, 3 and 1/8. Oops. Yeah, okay. And then at 6, it's 2 and 2/3. So you've got these 2 branches. So make sure you're drawing them so they hug the asymptotes. And then what's interesting is I have -1, -1/4, 0, 0, 1, -1/4. This piece in here looks like a parabola, actually. Do you see that? Now here's where the domain and range are going to get very interesting. Very, very interesting. So the domain is going to be all real numbers except plus or minus 3. Now the range. I need you guys to just stay with me on this range and think about it. Okay, y is greater than 2, or y is less than or equal to 0. I want you to stop and think about this one. I want you to notice there's this big gap from the horizontal asymptote to the next point. It's not ever going to come up in that region. So what I told you in the previous lesson is that even though when we were talking about range, and it tended to be that the range was just not the horizontal asymptote, and I said, be careful, that's not really going to be true in general. Here it is. The y values are above 2 everywhere here. There's nothing in between, but now notice the reason why I said or equal to on the 0 is it does touch 0 here, and it's everything below. Alright, so I have vertical asymptote, horizontal asymptote, a table, domain and range. Let's do intercepts. What's nice is the x and y intercept are both 0, 0. Alright, questions on this one? Just make sure you watch the video too. Alright, let's do the third one then, because this is the one that's going to have a slant asymptote to it. Okay? So here we go. Example 3. Graph y equals x squared plus 3x minus 4 over x minus 2. We're going to start with the vertical asymptote. You set the denominator equal to 0. Now I'm going to check for the horizontal asymptote. The degree of the numerator is 2. The degree of the denominator is 1. Let's go back to the chart. When the degree of the numerator is bigger than the degree of the denominator, there's no horizontal asymptote. But the note under the box said if the degree of the numerator is exactly 1 more than the degree of the denominator, there's a slant asymptote. And in order to find it, you do long division. So I'm going to take x minus 2 into x squared plus 3x minus 4. If you remember from our previous chapter on long division and synthetic division, if you do divide by x minus a number, we could do synthetic, but because some of these are going to get complicated, I want to practice long division. So this will be times x. So I get x squared minus 2x. I take the opposite and add. And then x times what is 5x? That's a 5. Take the opposite and add. Now my slant asymptote is just y equals x plus 5. Now there is a remainder, but let me explain something to you. And this really is related to calculus. A slant asymptote is still looking at as x is going to infinity. If x goes to infinity, 6 divided by infinity is 0. So that's why you don't ever do anything with the remainder when you're describing the slant asymptote, okay? So it's still y equals x plus 5. All right, we're ready for our table. Good news, we only have one slant asymptote, or excuse me, one vertical asymptote, sorry. So that's 3, 4, 5, 1, 0, negative 1. All right, now this one's kind of complicated, so let's go to our graphing calculator. When they get more complicated, we'll let the calculator generate the table for us. So go to your Y screen, and you have to be very, very careful. When you enter a fraction in the graphing calculator, you must put the numerator in a parenthesis and the denominator in a parenthesis. So check yours that it looks like mine. Parenthesis, x squared plus 3x minus 4, close that parenthesis, divided by parenthesis x minus 2. Then, to get the table, you just do second trace, and that's where the table is. And you scan up and down. Notice that x is 2, it's giving us an error, which it should, because you can't divide by 0. That's a good thing. So then let's fill in our table. At 3, I see 14. At 4, I see 12. 5, I see 12. 0, 2, 2. Let's go ahead and start our grid, but we will go back to the graphing calculator. To see what's actually happening and to help us with that range. So I have a vertical asymptote at x is 2. Now, do not panic with your slant asymptote because this is actually an Algebra 1 concept. Y equals x plus 5 is a line. Y equals mx plus b. You know how to graph that. You go up to 5, And then you use the slope, rise over run, rise over run, rise over run. And then make a dashed line through that. All right, now let's go back to the graphing calculator a moment. And I want you to press window. On those y values, did you see it went up all the way to y is 14? When you use zoom 6, which is the standard window, that only goes -10 to 10, and you'll miss part of the graph. So we're smarter than our calculators in that we know it has to go up higher. So you press window, and I want you to notice I changed y max to 16. That's the only thing I changed because it'll go up higher. So go to y max and change it to 16. Now let's press graph. And look at this. This is pretty nice. So now when I'm plotting my points, so I have 3, 14. So it's up here. And then here's the 12 and the 12, but according to this, it looks like this. So we're actually going to have to go back and extend the vertical asymptote and the slant asymptote, and that's okay. That's okay to have happen. And here's 1, 0, 0, 2, -1, 2. So, you know, like unless you looked at that graphing calculator, you're not sure what's happening there. So I have the vertical asymptote. I put down, please make sure you write down there's no horizontal asymptote. The slant asymptote is y equals x plus 5. I have a table. Now, let's do the x-intercept. I've got one at 1, 0, but it looks like it hits again, doesn't it? And so we're going to have to find that one. The y-intercept was at 0, 2. So let's go back, and then when we're going to talk about domain and range, the domain is all x except 2, but my range is going to be very, very interesting here. Do you guys understand that this comes down to some low point, some minimum here? But I don't know if it's 12 or if it goes below 12. So we've got to use the graphing calculator to find that. So let's go back to our calculator, and we have to find this minimum. So we're going to press second trace, and we're going to do minimum. So let's use the right arrow key. Press enter on the left bound. Move it a little bit to the right and press enter. And on guess, you can just press enter. So the lowest y value, it in fact goes below 12. And it's at about 11.9. So watch this on my range. It's going to be y is greater than 11.9, or greater than or equal to, right? And then we're going to repeat this to find this maximum. So let's do second trace, maximum. Okay, I did second trace, maximum. So let's arrow over. You still have to get to the left. Get a little bit to the right. On the guess, you can just press enter. And this one has a maximum of about 2.1. So that means it's 2.1 and everything below. So there's my domain and my range. And now we've got to go find that other x-intercept. So on my graphing calculator, do you see it's crossing right here? It looks like it's -4, but let's go find out if it is. So this is second trace, that's a 0. And again, we should be getting pretty good at this left bound, right bound business. So I get to the left of the 0, and I get to the right of the 0, and on guess you can just press enter, and it was at -4. So I had two x-intercepts, y-intercept, my domain, and my range. So let's take a moment and make sure this is all gelling. Do you guys understand that the domain is all real numbers except 2, because there's a vertical asymptote there. With my range, I have a low value or a minimum here. It hits at 11.9 and it touches 11.9. So notice it's or equal to, and then it's everything above that. And then there's a maximum here at 2.1 and it's everywhere below. So very, very tricky. And notice there's no y values in between. So you can't just say it's all values except some number, because that's not true. So we got through half of this today.